Hi everyone, I just wanted to record a little something here about our standard that we've been discussing about how the ocean is an integral part of the water cycle and it is connected to all of the Earth's reservoirs. Before we can move on, we really do need to understand what the word integral means. It's necessary. It makes some pieces complete. It's essential or fundamental. So the ocean, without it, would we have a complete water cycle? Think about how it might be different if the ocean was not a part. And to really put things in perspective, what I did with my son Carter, we bought an inflatable globe. And I've done this in the past, and I was looking forward to doing it with you guys. The directions are literally just to throw the inflatable globe back and forth. And every time you catch it, you would place a tally under either land or water based on where your right thumb falls. I managed to get Carter to throw it back and forth with me a few times before he decided he wanted to just kick the ball around the house. But our results were that 6 times one of our fingers landed on land and 19 times our thumbs landed on water. So what conclusion can we draw from this data? I know it was just a globe being tossed around, but how is that applicable to the real world? I also included a text called "Can you repeat that?" for those of us that needed a refresher on the vocabulary words. Some of us in our water cycle write-ups were missing very important words like evaporation, condensation, water vapor, precipitation. All of these should be addressed because without either of those pieces, any of those pieces, it would not be a complete cycle. This is just an idea if you are somebody who is trying to keep nice, thorough notes in your notebook, despite the fact that we cannot be in the classroom. So kind of our essential question today is, how is the ocean connected to the water cycle? Thinking about that activity where I tossed the ball back and forth, what did that tell us? How is it all connected? So I have this chart here. I know it's kind of a little blurry. I blew it up to be, full screen. So on Earth, water is stored in many places. Some places store more water than others do. Look at the table below. And after this, I'm also going to show a different video that I created that really puts all of this volume in perspective. So which place stores most of the water on Earth? And obviously, just looking at this, oceans, seas, and bays hold over 1 billion cubic kilometers, of volume. Compared to our atmosphere, very little. Next is surface water, such as rivers and lakes. And then after that, we have our ice caps, glaciers, permanent snow. So our next largest number is frozen. Another question that we have, I know we're not taking FSA, but it is still important to be able to use our test taking strategies. So let's say the 5th grade class we are studying the water cycle. I draw a model of the cycle as shown below, and we know that the arrows indicate the direction that water travels throughout the cycle. So what would you guys as a class be able to conclude about the ocean's role in the water cycle? I want you to take a minute, pause the video, look at your answer choices, and use your X's and maybe dots. Hopefully you actually did pause and looked through and realized that D is definitely a throwaway answer. Okay, lakes and rivers that store fresh water are not nearly as important as our ocean. We saw that they hold not nearly as much water. If we look at C, the role of oceans is not very important because of their high salt content. Water can still evaporate even if it is salt water. If you've left a pot of salt water on the stove too long to boil, you'll realize the water still evaporates and leaves the salt behind. So that doesn't quite work. The role of oceans is not as important as that of glaciers and ice sheets. Yes, there's a lot of water in those, but again, there would have to be more processes involved in order for those glaciers and ice sheets to melt and then evaporate, etc. So A, The ocean plays a key role in the water cycle as a source and a storage unit of water is our best choice. So if you decided to put all of this in your notebook, you don't necessarily have to write word for word, but I would be jotting down exactly the importance that we've discovered here for our water.
So now that we understand what we're working with in terms of the amount of water on the earth, I wanted to show you this model here. If we were to pretend that we had a water bottle and 1,000 milliliters of water, in this case, we're using to represent all, okay, it's a little tough to see, of the water on the earth. So we should know by now that a model is a limited representation of an object because we can't actually do this experiment with all of the water on the earth. And it's to help us understand the structure or how all of this really breaks down. And again, we did say that this was to represent 1,000 milliliters of water. So I'm going to take this time and we're just going to very quickly color it blue. So this is to represent all of the water on the earth. You can take the time later and color it in fully if you really want to. So if I then were to take all of this water, I want you to take a moment and predict, if I were to separate it now from all of the water on the earth, how much of this would be salt water and how much of it would be fresh water. I want you to take a moment and go ahead and make a prediction here and here. That should total 1,000 milliliters. So after actually breaking it down, scientists have realized that all of the salt water in the earth actually totals, I'm going to use a text box here so that way it's a little bit easier. Surprise, 972 milliliters. It's an awful lot, leaving the amount of fresh water on this earth to be a whopping 28. So that way you have that visual. If I were to actually take this 1,000 milliliters of water and pour it on out, 972 milliliters of water is, if we're thinking about this as counting by hundreds, this counts up to about 800. So we're going to go a little bit above here to represent about 972 milliliters. That is how much of the water on our earth is actually full of salt, leaving our fresh water to be this teeny little amount right here. So although we know that the ocean, we can see now, definitely is a hugely important part of the water cycle because, as we can see, it carries most of our water. But from there, if I were to take this bottle of fresh water and divide it into all of the different types of fresh water that we can find on our earth, we know that we are starting with 28 milliliters. To divide that now, that teeny little bit of 28 milliliters, keep in mind this is still representing the entire earth. Our ice caps and glaciers hold only 23.5 milliliters. That's a little tough to see here. If I were to color that, way down here. Pretty shocking. Okay, obviously we can't be drinking the water that is found in our ice caps and our glaciers. After that, we have groundwater. Hopefully you, from your readings, this is the water that's stored in our aquifers, drinking water that comes from runoff. So that is a whopping 4 milliliters. I'm going to draw a smidge of water at the bottom of that bottle. Lakes and rivers have 2 drops. Go ahead and type that in there since it's kind of small. They only have 2 drops of the world's water. Put it so we can see it here. And the amount of air, that is found in our soil, okay, kind of seeping down into the ground, or found in our air, in our atmosphere, within clouds, we should know by now that that's found as water vapor, is a whopping 1 drop. So I want you to take a moment and really reflect on these questions that are found at the bottom of the page. I would love to see your thoughts. Okay, when you picture this is all of the amount of water on our earth. Let's see here, change up colors. This is everything that we have. And when it comes down to it, the only amount that we really have available to drink, okay, right about here, maybe it puts things in perspective. So were you surprised at any of the amounts? Maybe do you feel the need to conserve water more than you did before? You should be able to explain what the bottles represent. But the biggest piece here, does the amount of water in the earth ever change? The answer is a resounding no, okay? All it does is moves around. As I said in an earlier video, if you watched it, we are still drinking the same water that dinosaurs were drinking millions of years ago because the water just continues to circulate. It is called a water cycle because no 2 water droplets have the same journey. A lot of those water droplets might stay in the ocean for a long time, considering when you look at how much of it is actually salt water. I hope this was helpful. I am going to have one more video just to kind of break down a little bit more the importance of the ocean to the water cycle. And I hope and look forward to seeing your reflections.